Yeah, good evening to all. This is Vishwanath SK. Hope you are audible. I am audible to you all.
Yes.
Okay. And as Garima is already, just to inform, welcome you all for this electrical learning portal program. And I'm very much glad to connect you all for this training session. Okay. And today I'll be able to give as good as very good content and very good the requirement what you are looking for substation design actually. So today we are going to talk about overview about the substation design. Before that substation design, as a little bit to introduce of myself, and as already Garima told, I have almost more than 22 years of experience in the field of electrical and automation. Basically, I'm a power system, done a lot of electrification project in the tenure of when I was working for ABB India Limited. So almost more than 15 years I worked for ABB India Limited. And apart from that, Grasim, JSW and other industries I have worked. Okay. And I have expertise in design, basic and detail engineering of electrical, substation designs, technical sales and supports, plant operation and maintenance. So started career with maintenance, and then slowly I moved into the projects, and then I went to the design and the engineering. And also apart from that, I work for a different process plant like steel plants, cement, material handling, mining, ports and container terminal. So these are the very much important domain where I work for process also, and even I work for a substations actually. Okay. Hope you can see my presentation.
No, sir, it's not visible. Only your face is visible.
One second. Now, is that visible? Anyone can tell? Is it visible now?
No,
No,
sir.
sir.
No, still not visible.
One second, one second. Just a minute. Just. Now, is that okay? Sharing is coming?
No, sir.
Yeah. Now, is that okay?
No, sir.
Yeah, yeah. Okay, okay. Just a minute. Sorry for the inconvenience.
No, it's coming.
Am it's coming?
Yes.
Okay. Yeah, thank you. So as I told, apart from the process industries, I work for steel plants, cement, material handling, mining, ports, container terminal. The different process industries have a different various of requirement, but electrical remain the same, but the load and the process requirement will changes. Based on that, I work and I have expertise in these kind of process industries. Apart from that, I work for AIS and GIS complete up to 132 kV level, and good understanding about the IS, IEC, IEEE, and other UL standards actually. And during my work with these companies, I come across work with Steel Authority of India Limited, SAIL projects, Vishakhapatnam steel plants, Tata steel plants, about the steel plants, and JSW and JSPL. It's gone actually. And apart from that, NTPC, Adani, Mombasa, RCCPL, Hindustan Zinc, Andritz, L&T, these kind of companies I have worked, I understand the requirement and they specify. And even the
Your
consult
voice is
Voltec,
breaking, sir.
Macon, DCPL support with them, they understand actually. Okay. Sorry, some internet, maybe some issues. And I work for consultant like MN Dastur, Holtec, Macon, and DCCPL and TechPort. So with these consultant, I have gained the experience and knowledge working with their standards and specifications. Something like that. See, if you see why the training requirement and approach. See, learning is always a continuous process. If you see, now also I can learn. Now also today, day-to-day basis, I used to learn. So learning is a continuous process. Why the training is very much required is that basically to improve the skill sets improvement, detailed knowledge of all the product and services. See, wherever you work, whether you are in engineering stage or you work in a marketing or you work in a testing and commissioning or you work in a maintenance, you should know the knowledge of that product what you are using. Okay. Again, electrical remains the same. Okay. But the product and the services what you're using, you should have the better knowledge. For that, you require the training and understanding the customer business and the process. Always when you do the marketing stage, you require to understand the customer business and the process. Okay. And then the focus on the product specification and the application engineering. Then the important is the how value add, that is innovation and customization you will add to value to the customer actually. And while doing the engineering, it's very important. Today's word, cost optimization and the value addition is very important. Otherwise, we were not in a place we won't get the orders, or even we can say that we will not bring any importance to the company actually. So winning the trust and the confidence to the customer and as well as internally and improve overall the business is very key important for this training session. So just to show something about learning, training and instruction practice, it's a small steps towards the success. Okay. And knowledge is a nurture and knowledge is always a power. So learning, keep learning always. I can say that one. So when you go to the marketing function, the go beyond guaranteed technical particulars or go beyond the standard solutions or acquire a updated technical knowledge. If you are in a marketing function, no more. It's just okay is not enough actually. So you should have a pure technical knowledge when you go and discuss with your customer to gain the projects, to gain the orders, and to gain the trust of the customer. When it comes to tech engineering, the one who is working in engineering, who is not into only engineering design, look to into the innovative system solutions and also incorporate business sense in the solutions, acquire detail, know how to customer process, cost optimization, innovations. These are very important while doing the engineering. Then integrated approach will be value-based selling, whatever you do the work for your companies. So today, as I discussed in our training program about substation automation, substation design, what we are going to have a syllabus. We will quickly go through that one, and hope you already have received it. And little bit on the against each thing, we would like to add the what all the things we are going to cover up actually. This is not the limitation or what we have indicated here. We can go a little bit ahead of all this also whenever while all going the training actually. Now you can say the single line diagram, what you have indicated. See, the single line diagram for any electrical person is very important, whether it's electrical or automation or electronics based. The single line diagram is very important. And in single line diagram, we talk about power distribution and study of the loads. Something power distribution where about the uh, process loads, and we talk about the non-process loads, and we talk about the emergency loads. Okay, we have to
Excuse me,
segregation of,
sir.
yeah.
Sorry to interrupt. The slide is stuck up, I think so. Whatever you were talking about, the slide is not changing.
Now it's correct. Okay, it's coming.
No, sir. It's just on introduction page, second page only.
Okay, okay, just a minute. Some issue are there actually. Now is it coming?
Yes, sir. Now visible.
Yes.
It's coming, but it should be synchronized with your whatever the instruction.
Now it's okay. It's coming. Next slide. It's working.
Yes. I it get it. We got it now.
Okay. Okay. Yeah. Something sometimes issue with the Wi-Fi and something like that. Yeah. Coming back to the single line diagram, what we are talking about, the power it's not like single line diagram means just like that you draw some lines and then do the things. Before, how the single line diagram has been prepared, what is the input data, one should look into that one while doing the project. We give the experience and we give the details about the how the power distribution and study of the loads will be done. Something like that. What you can say that segregation of the loads as per the process loads, non-process loads, and then what you can say that the emergency loads. Emergency loads always which will during the normal power it will work, and then after that it will switch over to the DG set actually. Again, process loads will something where it is very important from the process point of view. All of you know, non-process nothing but you have you can say that you can ventilation, air conditioning, welding, all the non-process loads. In terms of process, the conveyors, you can say that a little bit on the production side. So these are related to the process loads actually. Then we talk about once we make the process and the load distribution, we prepare the SLD for the what you can get, say that we do the grouping of MCC feeders. Once we do the grouping of MCC, then we talk about the number of PCC. Once the number of PCC has been made, what is the number of transformers are required? And then after the number of transformer, we go into the number of ST panel required actually. Okay. And then this is how the ST to LT single line diagram, we will show you how to make that one. Then apart from that, we talk about CTPT, the associated equipment involved in the SLDs. CT, PT, surge arrestor, NGR, all these rating select, including VCB, ACB, all these rating selections, how to rating has to be done, calculation. We will show you and make you expertise while during our training sessions. Then apart from that, the very important heart of the system is the main and auxiliary protection relay selection for HV and as well as LV. Then about the coming back to the bus bar selection, about the basis of bus duct cable, we will talk on the discuss about the design criteria as well as sizing calculation. See, while doing this single line diagram or for any electrical, one should have a codes and standards understanding is very important, because anything which codes and standards about the IS or IEC or IEEE or even CVIP manuals, these are all very important while one who is doing the electrical design actually, substation designs, because these are the document which everyone will be referring, and whether it's equipment manufacturer or consultant who is referring to these IS, IEC and IEEE standards. So one should understand about what kind of a standards available. For example, IEC 61439, for it is very much required for LV equipment. Coming back to ISO 61850, it is for the communication protocol for the medium voltage switchgear. for the relays. Then we call about very, very important for the medium voltage switchgear, IEC 62 to 7100-200, which is used for the medium voltage switchgear. So like this, these are the IEC and IEC protocols standards we should understand. Then we talk about the different voltage level. So when we understand about the project, when we come to know that what is HV voltage, what is medium voltage, and LV control, and including control voltage, which is very much understanding for the start of the project, we will able to explain on this. Then about the substation layouts. Once you understand about the single line diagram, then we talk about little bit on the typical equipment layout. It consists of whether indoor substation or even the outdoor substation, because all these equipment substation is in coordinated in syncness with your SLD as well as equipment GA drawing. And then once you make the equipment layout drawing, how you should be able to give the civil input to your civil construction department. Okay, so it's first equipment layout and then we go with the civil input. Hope you can see now. Next, my slide. You can see my next slide.
No, sir. No.
Oh, it is getting stuck actually. Now it's working. Okay. I think when I made it in this one, it's slideshow. It is showing like that. Actually. Yeah. Now, hope you can readable this one.
Yes, sir.
Yeah. So next, the substation switching equipment. We talk little bit. We'll discuss on this. What are the indoor substation equipments, outdoor substation equipment, and compact substation equipment? Indoor substation equipment, we discuss about, say, switching equipment is basically your GIS equipment or AIS, VCB. You have isolators, okay, and ACBs. These are all switching equipment. Apart from that, we talk about outdoor. Same, we have outdoor equipment and compact substation equipment. Then we talk little bit on the, once we go in depth of the subject, we discuss about the instrument transformers. So how the CTPT sizing will be done? What is the CTPT selection criteria? What about the CT knee point voltage calculation? On what basis we should be able to select? Okay. And then we discuss about the voltage drop calculation, about the basic, what is the voltage drop calculation one should consider. Because voltage drop is very, very important, where your equipment required functional very well. These voltage drop calculations are very, very important, whether it is bus, whether it is a motor starting, HT motor starting, or your MV and LV cable. In MV, okay, it will not get so much of issues in terms of voltage drop calculation because of lesser current. But in LV, I'm sure once you cross more than 50 to 100 meter, your cable sizes changes. Either you should change to copper cable or you should change the what you can number of runs you need to increase. Because why the cable is very, very important is that we can go to next point. We can discuss about the cables, and then about the transformer sizing. While doing the your load sizing calculation, about the when you do the load calculations or distribution of the loads, we will teach you how to do the transformer sizing calculation, and we'll talk about more medium voltage motor starting, then load and diversity factors, and data sheet preparation for the transformers. See, these are the transformer and MV panels are very, very important for any substation. One should not make any mistake in compromising or derating the specification actually. So understand, because these are the very, very important in terms of operation of a substation. Then the equipment like VCB, what is the ratings available in VCB selection criterias, what we should be able to do that derating when it's go to ambient or more than 50 degree, when we should be able to use the VCU. So these are the things we will able to talk when we come to this topic. Then we talk about the cable selection. So every project and anywhere if you go, the cable is required. Whatever you do the digitalization or anything, but cable is very, very important in terms of any project. And everyone agree that this is a very much pain area or a problematic area when you do the cable selection, or even cable BOQ. Either you have excess of cables in your site, or you will have a shortage of the cables actually. So before going into the BOQ or schedule or sizing, one should understand why this, what are the type of cables available, how do the we do the selection of these cables based on the short circuit, based on the load, based on the voltage drop, and how the derating factors can be used, and the cable sizing and routing, schedule, and preparation of BOQ. It's a one of the biggest topic what we make during our course of discussion also. Then apart from that, the surge arrestor, earthing, DG sizing, power system protection, this DG sizing, all the sizing calculation, we will show you how to make for any substation. Then very, very important, the 14th point is the power system protection actually. If you see the power system protection, the selection criteria and the type of relays to be used is very, very important for any electrical engineer. When it comes to medium voltage, what should be my overcurrent? What should be my earth fault? Instantaneous, I should select. And if you see, it's not only limited to that, the type of relay, the type of protocol we should select, either Modbus, we should use Profibus, or one should use IC67850. Then what is the IOs are available? What is the DC voltage one should use? Okay, and then apart from that, the relay selection in LV, whether we should go for relay or release. And apart from that, the main protection relays, the protection related to unit protection, what we call it as a transformer differential protection or the distance protection, or even up to the distance protection or under voltage or old voltage protection. These are the unit protection. We will make you selection based on the single line diagram, what you can able to provide or what we can able to teach along the course of the action. So once the engineer should able to read the single line diagram about the protection, I can say that it's 20 to 25% of work is completed. Then we talk about the battery charger, which is used for the DC volt application for the medium voltage switchgear relays, which is very, very important. So these are the 15 topics we are going to discuss on the schedule what we have made. We'll give the schedule also on each day what we are going to discuss, how we are going to discuss, and what we are going to discuss. Okay, and then the next slide we talk about the substation safety aspect. See, anyone once making the hope you can see the next slide. Hello.
Yes, we can see.
Yeah. So now you can see that any electrical, hope you all agree, safety is a, why I kept this slide as the first is, for me, working is safety is very, very important. After that, everything comes. Whether you do a design, engineering, whether you be there at site, you be at maintenance, or you be at testing and commissioning. So safety is the first most priority, and safety should be individual responsibility. Okay. So what one should consider safety aspect actually in terms of design of engineering actually. Safety is important about the what kind of a material or what kind of a specification you are going to use or prepare while doing the engineering actually. And what is the clearances while using the design you will consider. And what is the material in terms of application. For example, you are using the port application. Will it be normal CRCA paint shade will be useful? No. Yes, it will work for a certain time, but after that, what will happen? It will get started rusting. So what kind of a material we should use once we using the port application, or what kind of a cable trace we should use when we using in the port application. And similarly, when we are using the cement plant, if you see cement plant, people will use LV panel with a drought type design. Why it is drought design is required? Because they don't have much of time to replace or repair actually. It's because continuous production will be going on. So based on the application and based on the site, we should able to properly design and do the engineering works. Whether it is engineering or material selection is very, very important. Apart from the proper clearances and spacing, what we do. Once we do this one, next part will be while doing the electrical drawings review in the MV panel or LT panel, one should look after the interlocking in the circuit diagrams. So interlocking is very, very important. Make sure that it is safety for the equipment, also safety for the human beings. To give an example, for the during the motor starting, one should be able to trip the motor on under voltage so that it should not give a harm to the motor. That is an example. And while doing the earthing, if you are doing the earthing, they make sure that the main circuit breaker should not be closed. So something, these are the few, just I'm giving an example where interlockings for each type of feeders, when it comes to the substation, outgoing feeder or incoming feeder, or motor feeder or a capacitor feeders, what we can talk, we have to give the proper interlocking in the circuit diagram. Then it's not stopping there only. Apart from that, we have to use the safety materials during the site activities and after the site installation during testing and commissioning. And then use of the, I fully recommend for the people who going to use the engineering or who are at site or who are at different positions, I always recommend for ST panel, please go ahead with the OEM panel. OEM panel is nothing but ABB, Schneider, Siemens. These are the OEMs which they follow. Why the OEM panels? I will talk little bit on the subsequent slide about the OEM panel. So these are the few safety aspect which I put it on this slide. Then comes to the what you can call it as a the standards, what we talked about a little bit earlier. These are the few listed IEC day-to-day basis we are normally use for our design, or you can say that manufacturing various activities. For example, IEC 62271 we use for medium voltage switchgear. IEC 634 we use for motors, 61850 communication protocol. Similarly, IEC 485, IEEE 485 used for the sizing of lead acid batteries. And similarly, I listed about little bit IEC and IEEE. When I understand few people are working from globally also. When global we work, always we should look after the IEC standards rather than IS standards actually. So because IEC is the one platform everyone will go through that one. IS is nothing but a sub part has been taken from the IEC. When it comes in India or anything, people still use a lot of IS document. For example, 2026 or IS 1180 for power and distribution transformer. If you see it's not only we are discussing about these things on the papers. We'll also give the little bit on the clause numbers what to be used. For example, IS 2026, IS 1180. We will glance through this document while doing the technical data sheet. How we should use these IS or IEC documents while preparing either preparing the data sheet or preparing or reviewing the equipment drawings actually. Okay, for example, how we should select the percentage impedance for 2 MVA 6.25. For example, okay, and what is the flux density we should use as per latest IS 1180. Hope everyone knows in India now the latest distribution transformer up to 33 kV class we have to use IS 1180. It talks little bit on the flux density, it talks little bit on the oil and winding temperatures. And then we talk about IS 30434 for earthing and then harmonics for IEEE 519. So these are the standards which describe the process, methods to ensure safety, reliability, and performance of electrical system. Okay, and everyone will come to one platform because you cannot say that I am using this method of diversity factor, this method of design practice. But when you say this is a clause number and this is IEC document or this is IS document, everyone listen and everyone will give a respect for those things what you can share it with them actually. And also when you do a designing based on these, or when you review these based on these documents, people you trust about what you're doing. Okay. So now you can see the next slide.
Yes, sir.
Okay. We talked about the codes and standards, little bit IS, IEC we discussed. And we talk little bit when we're doing the design about the site condition. What is the ambient temperature in the site condition? What is the what you can say humidity? Because site condition is the ambient temperature while doing the electrical is very important. For example, if you go 50-degree ambient, you are totally little bit the design will changes. Your the cost will goes up. Why? Because you need to derate. For example, for particular cable, you are derating factor for zero point 0.9, it's for 45 degree, 0.95 for a 0.9 for 50 degree, and 45 degree it is 0.95. So site conditions and the atmospheric condition, as I discussed about the port application or cement or the steel plants or even mining, is very important to know about the site condition, the ambient temperature, the atmospheric dust level for your designing the equipment. Even we discuss about little bit on the site condition, which comes about your what you can say that seismic zone of protection. Hope you first time you are hearing, it's okay, but this is the one of the important function where you will the more not everyone will go and test this design of this panel as per seismic. It is basically it talks about the vibration of the panel when the seismic zone occurs, seismic occurs actually. Basically your earthquake or happens, so that your component should be intact with your panels and all. We also talked little bit discuss on the routine and type testing for the equipment one should consider. And without the type testing of HT panel, one should not pass it on or we should not clear the drawings actually. So routine, the type testing for equipment. What are type testing? Basically, the IP protection, the short circuit, the temperature rise, the power frequency, and impulse withstand voltage. This one should HT panel OEM or the say two-tier vendors, what we can call, they should have these kind of a approved type test. Type testing has been done at the reputed laboratory like in India, what we can call a CPRI and ERDA. Then next comes to the make of the equipment. We also will give it in a training about the what kind of a make of equipment which are useful, because make of equipment also will make your life easy while choosing the equipment, because not only give the performance, their sales and services always are better when you're going with a good make of equipments. And we'll talk also about the enclosures, NEMA standards, and IP protection, very much required for while choosing the electrical, the GA panels, about the panels. And already, as we discussed about the various interlocks, we are going to talk on that during our training sessions. Various protection schemes, equipment data sheets, lockout and tagout actually. Lockout and tagout is very important for any, what you can say that lockout and tagout is very important while doing the designing, as well as during the testing and commissioning and during even the maintenance. Because I'm being coming from the maintenance for my first 3-4 years, because without lockout tagout, it's very much dangerous and it's not a good practice when you don't understand about the lockout and the tagout. And also we discuss about the safety items. So all these items, we do the design selection criterias, or we show the data sheet, or we show the specification during the our detailed discussion during our training programs, because these are all things we I come across during our my design practices. For I'm talking about the industrial projects, not on the commercial projects. Okay, I have a I can say that these are the very important the factors which is required for industrial production, industrial type. When you go to Tata Steel, the safety and the aspect will be much higher than other companies. Okay, just give an example. Then we talk about while doing the design is very, very important for any HT or MV or LV panel. What about my voltage, power frequency, and the impulse width and capability of the panel? For example, if you go to 6.6 kV, it should have a power frequency of 40. You should have a impulse width of 60 or even 28 for the power frequency. Okay, these are things which one should read out while doing the design or reviewing of the vendor drawings. Know about these power frequency and impulse frequency withstand voltages for any equipment should be able to do the design. And you should ask the OEMs about these type test reports. This will be the type test report one time they will do. They will not conduct in front of you people. Only power frequency they will do. Impulse they have a approved laboratory they have already done. Then about the while doing the design, we discuss about the air clearances required while doing the design of the panels actually. What means the clearances are required while one should consider while designing the equipments. Basically, the clearances you required very much required once using the outdoor switchyards, which will be designed for above 33 kV level. What should be my face-to-face clearance? What should be my face to earth? What will be my section clearances? Okay. For the indoor panel, only you have to see the face-to-face in the within the bus because within the panel you will be finding it out. Apart from that, your LV cable box in a transformer or HV cable box, face-to-face and face-to-earth, you need to look after actually. This is a little bit on the clearances we should consider while doing the designs. Then we talk about already we talked about the cables. The cable derating factor, we should refer from the good manufacturer like KEI or Polycab, just to take an example. Okay, from there the catalog you need to refer for a derating factor or the continuous rating of a cables. Now little bit I gave about the design aspect while considering an electrical equipment. So once we starting the substation design, okay, let me take into the little bit on the substation, how we want to do the substation design. Okay, so substation, once it comes, if you say the voltage level, you should understand whether it's an indoor substation or it's a outdoor substation. And in substation also, substation is something, is an electrical installation where power is controlled for transmission also and distribution also. Okay, hope I am not going so fast. Hope everyone is okay. Hello.
Okay, sir. Okay.
Yeah.
Yeah, okay, sir.
Yeah. So now the substation, whether it is a transmission and you are generating the voltage, your transmission level, your power you are generating, there also you require the substations where you need to transmit, convert from the low voltage to high voltage, and then you need to transmit over a transmission line for 420 kV or 242 or 145 kV, nothing but your 400 or 220 or 132 kV. And while distributing is very, very important, you should not have the someone can mute because it's disturbing. And substation for the distribution end, you can say that once it comes to 132 kV, what kind of a voltage it is coming to the plant, we should check it out. And then further, it should be distribution at 11 kV or 6.6 kV. Always your motors are at either 11 kV or 6.6 kV motors. Even sometimes the people also will take the transformer 33 bar 415 kV or 11 bar 450. So the distribution voltage and converting it up to 11 or 6.6 kV, that is very, very important in terms of distribution. So this is a typical little bit basic substation design, how the generating station to the transmission, then transmission line to the subzone, and then it was used for your utility or industrial application. See, whenever you do the projects or whenever you go to the any work in an industry, always you will find the medium voltage. Whether medium voltage, it's 132 kV level or even 66 or 33 kV level. After that, it is converted into 11 and 6.6 kV based on your usage. and then it will be used for 415 or 433 volt, what we call, and then control voltage about 110 or 220 volt DC or 230 volt AC. So always what we can say that we will convert these voltage, how the voltage, the segregation has been done. See, IEC 60038, if you see, they segregated the voltage, LV voltage, you can say that less than or equal to 1000 volt or 1 kV. Medium voltage up to, we call it as 36 kV or 33 kV, we segregate into medium voltage. Then high voltage, what we can call it as 33 kV till 220 kV. Okay. And from about 220 kV, we call it as extra high voltage, and 1050 onwards, it call it as, that is ultra high voltage, the voltage is actually. Okay. One should know these things, very, very important, because you cannot do the 66 kV or 132 kV on indoor substation. You have to go for outdoor substation, outdoor switchyard, what we can call. And then the kind of a design and everything remains totally different, but you will see the same kind of equipment, but it will be a different switchyards, a different type of installations, different approach will be there when you do the switchyard designing. When it comes to indoor substation, you will have a different type of a design where you will, all your equipment will be mounted within the enclosure or within the building actually. So one should understand about this voltage level is very, very important while sizing the substation design. As I discussed about the single line diagram on the first slide itself only, we discussed about load distribution and what kind of a electricity board you are getting the power supply, and we will make you how the CTPT selection, demand factor. We will also choose the how the HV motor selection will be done, and what rating we should be able to see the HV motors, and again depends upon the process. And comes to bus bar, whether there's a single bus bar, double bus bar, 2 income or 1 bus coupler, what to select. Then about the cables, grounding system, and communication protocol. All this subject will be covered up in the single line diagram, what we have shown here actually. We will show you start from the low voltage till to the high voltage, how this single line diagram will be prepared. Right from the grouping of your loads to number of MCCs, first it will be made. Then from MCC, we will make a PCC. Up to what kilowatt motor will be designed in MCC. Then after that, up to what kilowatt motor we should take care, 75 to 150 or 200 kilowatt, we should go for the PCC. About 200 kilowatt, we should go for the MV motors. And then how the transformer will come into picture. Then what about the PCC ratings, transformer ratings, VCB selection. So all these things we will help you out creating the single line diagram. I'm sure once you create a single line diagram, then everything will be there on this place. You can easily design other equipments. And then we talk a little bit on the substation equipments. What will be the main equipment? What we should be engineering equipment? What should be the auxiliary equipment in a substation? What should be the civil? What should be the structure? Structure will come only for the switchyard. Please understand it. When it comes to, I just segregated what kind of equipments are coming in the outdoor. These are all different in outdoor substation. When you go to the outdoor substation, you will have a circuit breakers, instrument transformers, surge arrestors, isolator, power transformers. Okay. And we talk about control and relay panel, because all your controls and signals you have to bring into the control and relay panel into the control room, from where you are controlling the equipment. Only for the maintenance purpose or checking, testing purpose, you are going to the switchyard. But whatever you are referring to the metering, whether it is the energy, whether it is your how the performance of your equipment, anything which is protection, everything will be done from the controlling will be done from the CRP. And then we talk about the indoor substation. Everything, all these things will be mounted in the within the MV switchgear panels, power transformer, distribution transformer, control and protection, then power line carrier communication system, then next to the compact substation. If you see the utilities in your areas, lot of compact substation will be used. Why? Because you can't make the bigger substation every area. Okay, the compact substation you can make and distribute at 11 kV, and then it will be have a one RMU. In that RMU, you will have one VCB and outgoing disconnector switches. Incoming supply will come, and then outgoing will go to the next RMU, and then one outgoing will go to dry type transformer, and then it will go to the LT panel. From the LV panel, it will distribute it to the your local areas actually based on the voltage level, or even sometimes ST voltage only will come to your areas. So these are the, we will discuss in detail about the outdoor, indoor, and the compact substation while doing the design. One should come across during the your nature of work actually. And not only you require the, apart from the main equipment, you definitely require the auxiliary equipment to perform of your main equipment. What it consists of auxiliary equipment? There is a LT-AC switchgear panel, distribution boards, battery charger, DC distribution board, auxiliary lighting transformers, main lighting transformers, diesel generators, and UPS. Okay, because these are very much important to perform your substations actually, because substation where the lighting you will give, where the DC voltage you will give. Okay, for all these things you require one 630 kV or 1 MVA transformer is required for your substation, where it will distribute to your substation. And then the accessories like busbar material, earthing material, cables, cable trees, all these things are, we will make you understand while doing the design of the substation. Just I drawn one, we put it across the outdoor substation, how it looks actually. If you see the outdoor substation, it's completely a switch yard actually. Okay, it's an open yard where your equipment are installed actually. Okay, there is nothing roof or anything. You will find the your CT, PT, LA switch, circuit breakers, everything will be mounted outside. And here there are two types of design will be there. One is you need to make the equipment designing, individual CT, PT, circuit breaker, or LA, or transformers, post insulator. You need to buy from the market, and these has to be installed on the structures. So how the structure should be there? What should be the points to be considered? GI structures. Okay, if you see here, I can you can see over here the structures and everything will be come into picture actually. And then we have what you can say that indoor substation, where indoor substation you can see the all equipment are mounted within the inside the civil structures actually, civil substation. Okay, that is enclosed. Enclosed, what you can say that control rooms, what you can call. Transformer will be just mounted outside. So while doing this design, what all the points to be considered while doing the equipment layout, we will discuss in detail during our training program. How the medium voltage switchgear panel dimensioning will be done. What is the transformer dimensioning will be done. What all the database you need to create. And what is the, if you're using the battery charger of planted type batteries, what should be your separate room should be provided? What is automation rooms? And all these things we talk about your equipment layout. So once if you make the proper equipment layout drawing and dimensioning, definitely you have to supposed to do the civil assignment drawings. What is my cutouts need to be done? What is my insert plates? Because without these things, we cannot take the cables. And apart from that, what is the clearances between the panels we need to consider? One should consider all these things. We will able to explain while doing the design of the equipment layout. And then we talk about little bit on the compact substation. This is how the compact substation look after. What are the design aspects need to be considered? One should doing the compact substation designs actually. Okay, it's a very simple design, not much complicated thing. One RMA, one dry type transformer, and one LT panel. But one enclosure will be there. But for doing also, what all things need to be considered for this kind of a substation. and it is also extended up to, you can call it as e-house. E-house also used in the some of the what you can say that sometimes people can't able to construct for a very small setup actually. Okay, for example, very 2 MVA or 4 MVA load is there. They don't want to construct a very weak substation because it take a lot of time to construct your civil construction. So they go for a e-houses actually. That is e-house based substations are also available. So while doing the substation designs and calculations, so as I told already, the substation design, what you can say that mm, various sizing calculation involved in the substation design. We talk about power and distribution transformer sizing calculation based on the load. What should consider the diversity factor, load factor while doing the, it varies from where to process. When I suppose if you are using, we are using a cement plant where we use a zero point 0.6 to zero point 0.7, the diversity, combined diversity and the load factor. And what about the highest motor starting when we're using the distribution transformers, sizing calculations? What is the voltage drop at the terminals? So all these things we have to check it out. Why one should use the OLTC, when we should use the offload tap changers. We will discuss in detail when we're using the design of a power and a distribution transformer sizing calculation. Then it comes to a MGR calculation, MVLV cable, earthing selection, lightning protection, surge arrestor, DC load calculation. These are the various sizing calculation is required one doing the your substation design. So very much as I told that medium voltage cable calculation, what is the minimum size of the cable should consider while doing the MV cable? Because you should always consider the short circuit when you're calculating the medium voltage. What should be my durations for the incomer? What should be my duration of short circuit need to be considered, whether it is a 0.2, 0.4, or a 0.5 or a 1 second. Because higher the short circuit duration, your cable size will increases. Again, the cost will increases. But I should not compromise on the my tripping. So it should withstand for that particular short circuit. So all those things, apart from that full load carrying capacity, voltage drop calculation, the derating factor, all this we'll talk about when we're doing the real on live cable sizing calculations. We also show the typical sizing calculation and the schedule on in the Excel sheets. Hope it is a very important one should understand about this cable sizing, because cable sizing is the one everyone is required, as I told actually, and it's a very much pain area and is a little bit difficulty also. Okay, and as I discussed about the substation layouts, we have equipment layout, civil input, cable tray layout, then earthing design criteria. About layouts, we will cover up little bit on the basics about layout ones. And then if you remember, we discussed about the, what you can say that why one should go to the panel related to OEMs actually. Why can't we go with a second tier, the panel manufacturer? Because once people should understand why ABB, Siemens, Schneider, these are the one should go actually, because they follow ISO standard very much strictly. They have got very good engineering team, R&D team, and the manufacturing practices. Whatever the material they use, it has been going to the R&D team. They will test it properly. They will go in-depth analysis of that component before using into their manufacturing, because for them it's a very much name and market share. Okay, one bad name or one problematic in at one side, it will problem for their future order for that customer also and for other customer also. Today we are into era of digital WhatsApp and everything. The kind of negativity will go fast. So very much sure that these are the things which no one manufacturing OEMs will take it as it is granted actually. They should have very good testing lab for routine testing. And if you go and check it out, they have availability of all type test reports related to short circuit, impulse, temperature rise, internal arc, then even seismic zone also. Okay, and very good service after this sales. Okay, about the requirement, about the issues or troubleshooting, something like that. Then even other safety features and mechanical interlock, they will taken care in their electrical circuits actually. Okay. And also, for example, ABB, if you see, it complies with IEC standards been used for all over the world, wherever it is applicable. In Russia, GOST, GB in China, CSA in Canada. These are all certified agencies. With that, they have the certified and they can use in this panel globally. Similar case with Siemens or Schneider, they will also have a similar kind of a test report which can be used globally. So one should use the panels which is related to global standards, not on the local market. For basically, I'm talking for the medium voltage, where the risk is more in terms of a safety, electrical shocks, or even flashover or something like that. Okay. And now little bit typical one MV board I have shown you in one the what exactly it contains. Okay. We have just a typical example. This is you can say that we have a line in incomer come line PT. We have what you can say that the yellow color about the gas duct. We have what you can say that orange color operators, the pink color which is of metering chamber, a bus bar chamber, and down you will find the cable chamber. Hope you can see my the substation typical MV board, medium voltage board. Anyone can answer?
Yes, sir.
Okay. This is the
Yes, sir.
typical indoor substation panel. It is 630 or 800 mm or up to 1000 mm panel. We will teach you about how, depending upon the number of panels, we will how to design of. We are not going to design of these panel, but how we are going to use about these panel dimensions in our substation design. One should know for one panel what is the width of the panel, what is the height of the panel, and what is the depth of the panel. See, while doing the design, depth is very, very important based on your number of cables. Your depth is increased and you are given a very short of a cutout, then you will be problematic. You cannot able to pull the cable inside the panel. Hope you might have who has experienced, you might have come across these problems. So these are the we don't want to get a normal standard training. We want to give a practical kind of a training which really helpful for the whether you are a student or you are in a OEM side or wherever you are, you can understand the impact of each point what we are discussing while doing the design actually. Okay. And also, as we know, the medium voltage switchgears, which if you don't design properly, either you have a temperature rise problems because of the issue in the proper bus bar sizing you're not done, not clearance has been taken care, or even have a termination issues, or even have a flashovers if your not holes are closed properly. Okay, and these are a few problems I have listed out while doing the issues created after the design. Even a single small cables of single core you are using of that land plate if you are using the a CRCS sheet, which give a problem related to a proximity or skin effect, which will heat up your panel actually. So it looks very simple, but if you don't care and then something goes happen, then everything one should start where what went wrong actually. So in our design course of ELP, we will make sure that best design practices we will use while doing the design of any panels actually. And little bit this is about the what should be the MV switchboard voltage level, what should be the impulse withstand, what should be the frequency, short circuit time, internal arc rated. These are the few what you can say that ratings one should see before seeing the anything like what we call it auxiliaries. Before seeing into the auxiliaries, one should see about these electrical main important parameter for any electrical panel. For example, you have a 12 kV. For that 12 kV, what will be the test voltage? 28 kV power frequency. What should be impulse withstand? 75 kV. What will the frequency? If in India, 50 hertz. If you are USA, always you should tell where the which area or which location you are using this panel. If in India, it's a 50 hertz. If you're using in USA, it's a 60 hertz. Okay. Then what should be the short time withstand? Whether it is a 40K, 26K, 36K, 1 second, 2 second, 3 second. What should be your withstanding capabilities? Next comes to internal arc withstand, where it's a 1 second or 0.5 second. Then rating of your bus bar, type of bus bars. See, any of the manufacturer, if you go up to 3000, you have a normal bus bar, you will get it. Above 3000 ampere, only you will get the force ventilated bus bars. Okay, so you should clear about these aspects when you're using the panels from the vendors. Actually, you should know what you are going to get from the market and what you want required. Actually, it should not happen that you require 800 amps and you are putting the 1600 amp panel. It is not required. So one should not do the over design also, one should not do the under design also. Okay, in terms of for doing the cost optimization, it should be economical also, and it should meet your technical requirement also. Okay, and this is the main electrical, the parameters one should see for any medium voltage, high voltage, or the voltage equipments. Start from 6.6K to 220 kV or higher also. These are the very much basic requirement one should understand first. Then apart from next comes your relays. Next your comes about CT, PT, and other auxiliaries which are used in the system. Then we will about the ETAP or the AutoCAD. We will show you as a few things while doing the discussion actually. Okay, so this ends about the about substation design. We have given a overview about this substation design. Okay, it's a just startup or it's a beginning. I'm sure that the one today you can see your skill sets, and after the training program or something, I'm quite sure that you are enhance your skill set. One thing, you are confident while doing the design, or you are even confident once you're making the specification or data sheet, because these are all which comes from the good practices and good understanding actually. Okay, and the good connect with, for me, I have a good connect with these OEMs also, where I can able to refer, I can understand, and even about the connect with the people, I can get the a lot of information I can share with you people actually. Okay, and whatever we are shown about the point 1 to 15 about our, what you can say that the course of things actually, it's not that mandatory that I should teach only about, we should teach about only this much of portion. Even little bit go beyond this, definitely we will discuss and we will support you. Okay, and also always available. I'm on my WhatsApp, or even I'm available on my, you can send it to email, your queries or your requirement after training program also. It's something like that, a support we can do. It's also helping one with each other. Okay, you, someone is asked, sir Vishwanath sir, what supposed I should use? Definitely we can able to help out that guide. Our limitation is not up to you giving the training, even it is much beyond actually. Okay, and which you make you a successful engineer, a designer, and you can have a control on the subject. And also make sure that it's something that you can't learn everything in a short period of time, 1 month or something. As I already told, the learning is a continuous process. I also recommend some of the books or something where after our training also, you should read out those books which is helpful for your career growth. Okay, and you can also, the one who is switching your company, you confidently you can speak after your training program, you can confidently you can talk about what exactly you can do in terms of design aspect actually. Okay, and the trust will come when the engineers or your manager is working with you people. Okay. So this ends my training on substation, overview of substation design. Okay.